we're going to start out our final section of 2.7 with a proof of the transitive property of parallel lines. So this is a theorem that we need to prove. And it says that if two lines are parallel to the same third line, then they are parallel to each other. So if P is parallel to Q and Q is parallel to R, then P is parallel to R. It's what we're going to prove. So we're going to get there, all right? And we have a diagram to use in our proof. So let's go. We're going to start with our first given, that line P is parallel to line Q, and that's given. So from that, I do have angle 1 and angle 2 that are corresponding angles, and so based on our corresponding angles converse, I can say that angle 1 is congruent to angle 2. Based on just that first given and what I have in the diagram, that's all I can do right now. So I'm going to write down my next given, that Q is parallel to R, and that's a given. And so now I can look at lines Q and R, and I see that now angle 2 and angle 3 are corresponding angles. And so I can use the same corresponding angles converse to say that angle 2 is congruent to angle 3. And now I have angle 2 congruent to both angle 1 and angle 3. So I can say that angle 1 is congruent to angle 3 by the transitive property of congruence. And I know that my final line needs to be that P is parallel to R, and that is because 1 is congruent to 3. But what is our reason? So far, none of the theorems or postulates we've learned actually apply to allowing us to go from the congruent corresponding angles to the fact that they are parallel lines. We've gone the other direction, so this is where we need to go next. But for right now, I'll tell you what to write, and then we're going to see it on the next page. Okay? So our reason is the corresponding angles postulate. Okay? Which we don't have to prove in order to use. Okay? And you will find this on the next page in your packet. But we've been using the converse all along, and now we're finally going to use the actual postulate. But before we get to actually looking at the corresponding angles postulate, we have two more postulates we're going to get to first. Okay, so we're going to talk a little bit more about what it means to be parallel and what it means to be perpendicular. So we already know that parallel means that two lines are coplanar but never intersect. And perpendicular means that lines are coplanar and do intersect, and they form a 90-degree angle. Okay, so in our example at the top of the page, okay, in order to draw a line parallel to line L and going through P, there's only one way I can draw this. Okay, so I can only draw one. And for B, to draw a perpendicular line in order to make a 90-degree angle, again, there's only one way I go. If I go any other angle, it's not going to be 90 degrees. So, again, there's only one way. And so we have our parallel postulate and our perpendicular postulate that say, through any line L, okay, if there's a point P not on line L, there is exactly one line through point P that is parallel to line L. That's the parallel postulate. And there is exactly one line through point B that is perpendicular to line L. That would be the perpendicular postulate. Finally, we get to our corresponding angles postulate. And this is part of a group of postulates and theorems that, instead of using the fact that lines are parallel and then saying something about the angles that they form, now we are going to know something about the angle pairs that are formed when two lines intersect a transversal, and we'll use those pieces of information in order to prove that the two lines are parallel. These are going to be the converses of the ones we have already learned, and so since we called those the converse, these are the actual original postulates and theorems that those converses came from. So our first postulate in this category is the corresponding angles postulate, and so it says, if we know that when we have two lines cut by a transversal, and here this is this angle, so lines J and K are the two lines that I want to know if they're parallel. If I know that the corresponding angles are congruent, if that is given, then I can say that J is parallel to K. This is a postulate, so we don't need to prove it, and that's why we used it on the previous page. Now we have the alternate interior angles theorem. So we're talking about two angles that are cut by a transversal, okay? And if we're told that the alternate interior angles are congruent, then we can say that the two lines cut by the transversal are parallel. Okay, so that is our example here in this diagram. And we are told that 4 is congruent to 5, so those are alternate interior angles, and that is my given. Statement 2 says that angle 5 is congruent to angle 8. I can say that because we proved in 2.6 that vertical angles have congruent measure, are congruent and have equal measure. So that is the vertical angles theorem. And then based on the transitive property of congruence, I can say that angle 8 is congruent to angle 4 because angle 8 is congruent to angle 5 and angle 4 is also congruent to angle 5. So I can fill in 4 here. We know that the final line of my proof needs to be that line J is parallel to line K, but how do I get there from statement 3? Well, this says that 8 is congruent to angle 4, and those are both the bottom right, and so they are corresponding angles, and based on our corresponding angles postulate, which remember we didn't have to prove, so the corresponding angles postulate says that I can go from the angles to the parallel lines. So that was alternate interior angles theorem, and now we're going to look at the alternate exterior angles theorem, which is exactly the same thing, except now we're going to be looking at exterior angles to my two lines that I'm determining if they're parallel or not. So if I am told, if I'm given that angle 1 is congruent to angle 8, in this case they are alternate exterior angles, once I'm done proving this theorem, I will be able to then say, every time I see this scenario, that the two lines are parallel. So let's prove it. My first statement is given that angle 1 is congruent to angle 8. And statement 2 says angle 1 is congruent to angle 4. Well, angle 1 is here and angle 4 is here. So those are vertical angles. So they are congruent based on the vertical angles theorem. And then I have angle 4 being congruent to angle 1, which is also congruent to angle 8. So I can say that they are congruent to each other based on the transitive property of congruence. And I know that my final line needs to be that line J is parallel to line K. And to say that, I have to look at angle 4 and angle 8. And they are corresponding angles. So once again, my reason for statement 4 is corresponding angles postulate. Our fourth angle relationship theorem is that consecutive interior angles will also tell us if the two lines cut by a transversal are parallel. And in this case, we need our consecutive interior angles to be supplementary, so we'll have to be told that either in words or in an equation. And then we will be able to, once we prove this theorem, say that lines J and K are parallel. So let's do it. Statement 1, we are told that angles 3 and 5 are supplementary. Okay, and then in order to make statement 2, we're taking what we are given in words and putting it into an equation, and that is based on the definition of supplementary angles. Statement 3 is another statement in words, but it's not given. So now we have to go look at the diagram. So angle 1 and angle 3, they're adjacent angles and they form a linear pair. So I can make this statement based on the definition of linear pair. And then, just like statement 2, I can convert this into an equation. So the measure of angle 1 plus the measure of angle 3 must equal 180 degrees. And that is the same definition of supplementary angles that we used in statement 2. Supplementary angles. And now I have two equations where both things equal 180 degrees. So I have measure of angle 3 plus the measure of angle 5. And I have the measure of angle 1 plus the measure of angle 3, both equaling 180 degrees. And so based on the transitive property of equality, because these are equal signs, not congruency symbols, I can say that the measure of angle 3 plus the measure of angle 5 equals the measure of angle 1 plus the measure of angle 3. Within this statement, I can see that the measure of angle 3 is on both sides, and in statement 6, I only have one measure on each side, so that measure of angle 3 had to go somewhere. It was added, so in order to undo adding, we subtract. So it is subtraction from both sides, so that is a property of equality. And so I am left with angle 5 here and angle 1 here, which means if the measure of two different angles is the same, I know that I can say angle 5 is congruent to angle 1, and that is just because of the definition of congruent angles. I do know that the final line in my proof needs to be that line J is parallel to line K. And in order to do that, now we have to go back and look at the picture, and angle 1 and angle 5 are corresponding angles. And so once again, our ability to prove our final statement is based on the corresponding angles postulate. Now we get to use all of our theorems. We have to explain which lines, if any, are parallel, and we can't just get out a protractor. We can't assume that if they look parallel, they are, because we're told that the figures are not to scale. Not that they might not be drawn to scale, but that they're actually not. So let's look at example A. We have lines WZ and XY that we need to figure out if they are parallel. And then we'll look at the other pair in a second. In order to determine if they are parallel, we can look at either one of the horizontal looking lines as the transversal. But this line is the one that we know two angles on that. And so we can look at 60 degrees and 120 degrees. They are on the same side of the transversal, and they are next to each other. They're both inside, so they are consecutive interior angles. And if these two lines are indeed parallel, then these consecutive interior angles should be supplementary. So the question is, does 60 plus 120 equal 180? And sure enough, that's true. So WZ, line WZ, okay, is parallel to line XY because the consecutive interior angles are supplementary. Okay, so that's my explanation. And then I have to look at line WX and line ZY. Again, I need to look at the transversal that I have two pieces of information for. In this case, this is line XY, and I know 120 degrees and 66 degrees. Again, they are consecutive interior angles, so they should add up to be 180 degrees if these two lines are parallel, but 120 plus 66 equals 186. So lines WX and line ZY are not parallel, and we can finish and move on to the next one. In example B, we have two pairs of lines again that might be parallel that we have to determine. We'll look first at line R and line S. And for our transversal that we know two values on, that would be line P. And we know 100 degrees and 80 degrees. Those are exterior, and they are on the same side of the transversal. So we don't have any theorems or postulates that tell us what these two are supposed to be in relation to each other. Other than the fact that I know that this 100-degree angle and this angle here must be supplementary, meaning they add to be 180 degrees. So I know that this angle is also 80 degrees, and now I have corresponding angles, which are equal. So I know that line R is parallel to line S because the corresponding angles are congruent. Next, we have to decide if line P is parallel to line Q. In this case, my transversal that I know two angles on is line R, and I know 100 degrees here and 95 degrees here. Those are alternate exterior angles, which if lines P and Q were parallel, those angles would be congruent. They're not, so line P is not parallel to line Q. In example C, we're going to start by looking at line AD and line BC, and the transversal that we know lots of information about is this line right here, BD, and we know this angle is 50 degrees and we know this angle is 50 degrees. They are on opposite sides of the transversal, so alternate, and they're interior to the two lines we're looking at, so alternate interior angles. For these lines to be parallel, those angles need to be congruent. They are both 50 degrees, so they are congruent. So we can say that line AD is parallel to line BC because the alternate interior angles are congruent. Now we still have another pair of lines to look at. So we have AB and DC. And so the transversal I want to use is now line BC. And while I don't have any corresponding angles or consecutive interior angles, because this is actually 20 plus 50, but I can do that math. So that is 70 degrees in that angle there for angle ABC. And I do know that my consecutive interior angles should be supplementary, meaning they should add to 180 degrees. But 70 degrees plus 100 degrees does not add up to be 180. So these two lines are not parallel. In our next few examples, we're going to use the given information to determine which lines in the figure must be parallel. So we're going to look at first A, which says angle 1 is congruent to angle 3. Those are corresponding angles when line R and line S have M as their transversal. So we can say that R is parallel to S, and we'll say the same thing we'll write the same thing we just said, because angle 1 and angle 3 are corresponding angles when line M is a transversal of lines R and S. I won't have space to write the explanation for all of these, so this time it's the longest explanation. After that, we'll just shorthand that. All right, for B, we're looking at angles 4 and 5 being congruent. So 4 and 5 are along line S, so S will be the transversal, and that means that it is intersecting lines M and N, so those are my pair. So that means that M must be parallel to N, because then 4 and 5 are alternate interior angles. Okay? For C, we're looking at 3 and 6, which actually these are the same set of lines, and they are now alternate exterior angles. So we're going to say the exact same thing. M is parallel to N because angle 3 and angle 6 now are alternate exterior angles. In example D, we are told that angles 2 and angles 3 are supplementary, which means that because those are consecutive interior angles to lines R and line S, and they are supplementary, so R is parallel to S, and then it's because angle 2 and angle 3 are consecutive interior angles. Okay, last one says that 3 is congruent to 8. So these are actually completely opposite. So they are exterior to M and N, but on different transversals. So we kind of have to use a transitive situation here. So in order for those to be congruent, and the diagram we have, 8 and 1 are corresponding angles, and 1 and 3 are corresponding angles. So in order for 3 and 8 to be congruent, then I know that 1 has to be congruent to 8, and I know that angle 1 has to be congruent to angle 3. And so then by the transitive property of congruence, angle 3 can be congruent to angle 8, meaning that in this case, all right, we have to have R parallel to S and M parallel to N in order to make that statement, the given statement, true. In our next examples, we're going to find the value of x that makes our two lines m and n parallel. So in A, we have this angle here, 135 degrees, and this angle is 2x plus 15. And we have to figure out how those two angles are related. So they are both on the left-hand side of the transversal and above m and n respectively. So they are corresponding angles. Corresponding angles are congruent if those two lines are parallel. So I set 135 degrees equal to 2x plus 15. Subtract 15 from both sides, and then divide both sides by 2. So x equals 60 in order to make this one true. For B, my two angles are here, and those are consecutive interior angles, which means they must be supplementary, or in other words, they must add to equal 180 degrees. I combine like terms, divide both sides by 3, and x equals 60 in order to make m parallel to n in this case.